Hello, welcome to the video. Today we are going to look at how we can swap two values using XOR with no third variable, temporary variable. Let's begin. We'll start a new project. So cargo new swapper. Just call it swapper. Can be called anything. Change into swapper source. Then we will NV is just my Vim or NeoVim shortcut. You would maybe type Vim or whatever you want to call it with your editor. Right, we can get rid of the hello world. First thing we want to do is we want to define A and B. A and B can be 5 and 10 for the sake of keeping it simple. It could be anything. So in binary, you need to do 0B in Rust, and then we want to put in 5, which in binary we need to do that because we could do it as that, I believe, but because we're going to be adding double digit, let's do that. And we'll do B, which is going to be 10. And that is 1, 0, 1, 0. Okay, and then the first thing we want to, okay, we'll print them. So let's do A, comma, B. And let's run it. Saying take out the mut. In fact, this will come in handy later on because what I'll do is I'll yank this line and then reuse it. So if we go down here, there we go. A equals 5, B equals 10. Right, let's do the actual operation. So A equals A or B. Then we do B equals A. Sorry, did I say or B? I meant XOR. So this caret symbol is the XOR, so it's exclusively true or exclusively 1 or exclusively high if one or the other is high. Not if both, not if neither. And then again, so it's ABA, ABBA. If any of you know that the 70s Swedish pop band, then that's a good way of remembering it. A, B, A. So this, believe it or not, has actually just swapped two values. We'll look at some theory in a second, but actually let's put before. I know what I'll do. I'll yank it first. We go, and we'll do before. After swap using XOR. I'm just going to exit that and then do cargo run so that you can see it on the full screen. I'll do it quietly as well. So there we see cargo run. So before A equals 5, B equals 10. After swap using XOR, A equals 10, B equals 5. We swapped them. And I don't know, there's something like amazingly kind of symmetrical about that. You just do ABA and you do AX or B, AX or B. So the right hand side's the same each time. I guess it's whoever kind of discovered this was very, I don't know, perhaps they weren't clever, but I think they were clever. Okay, so let's look at some theory. The initial state, A is 0101, B is 1010. This is starting state before any XOR operations. So then A becomes 1111 because by doing A XOR B, 0101 and 1010, you end up with 4 ones. B's unchanged because you haven't actually done anything with it. So A has changed, B hasn't. Step 2, B is A XOR'd with B, because that's kind of the rule, the formula. So then B actually becomes 0101. So B there is actually becoming 5. So B is now 5, and that's what A started as. This operation flips the bits in B where the updated A as a 1. Okay, now step 3. So we need to get A how we need it. So A equals A XOR B, and because B's changed, we can do 111 XOR 0101, and we end up with this, which is working out as 10 in decimal. And we've modified A here, we haven't modified B, because we modified B in the previous step. Again, we XOR the updated A with the original B, and we store the result in A. The step effectively cancels out the bits that were flipped in A in the first step. So after the swap, A is 1010, B is 0101, which is very cool, I think. If you want to look at other bitwise operators, there is kind of they're very kind of neat and precise. I mean, for instance, Bitcoin uses it with the halving. So approximately every 4 years, the mining reward halves. And that's achieved by doing a bitwise right shift, which is those two. And you can do some really cool stuff. So bitwise operators, if you're coming from kind of maybe Python or something like that, yeah, handy to know. There is a swap function in Rust, but I think from like a computer science perspective, this is just like it's kind of something you should be aware of and probably memorize. Let's put in some different numbers here. Let's put in an extra one. Let's change that. Whilst I'm talking, I'm not actually going to work out. I can't think and talk at the same time, but I don't know what they are before. So what's that? That's 1 plus 4. That's 5. Skip the 8. So that's 16. So that's 21. Let's run it. Yeah. So you start off with 21 and 22, and you end up with 22 and 21. I put the code as a kind of Rust playground, a link to Rust playground in most of my videos. I'm not actually going to do it with this one because I think it's probably healthy to type this in from scratch and learn it if you've watched this video and you want to experiment. Type it in, probably memorize it if you can. Good practice. I think memorizing things is going to be something which we get lazy at and we maybe don't do as much in the future because of ChatGPT and Google, Stack Overflow, so on, so on, so on. But I think if you're learning something, my personal opinion, in my humble opinion, is the more you can memorize, you will become faster. And one day, if you don't have an internet connection, what with everything that goes on in the world, imagine you're in a log cabin somewhere in Alaska or the South Pole and you want to do some programming, then unless you've got some PDFs saved on you, which I would also recommend, save some PDFs with lots of information in PDF format books, because you never know when you haven't got an internet connection and you want to do some coding. So, and also standard library, learn as many or use as many standard libraries as possible. Frameworks are all very well, but that's why I did the recent video on using standard time instead of chrono. I know chrono has actually got sort of a lot better ergonomics and added bells and whistles, but sometimes if you can do stuff using the standard libraries, maybe you don't have to use them on day to day, but as long as you know how to use them, if you can never access a library for whatever reason. It's like, fine, wear slip-on shoes, but it's still good to know how to tie your laces up, isn't it? Thanks for watching. I hope you like these videos. Drop a comment and stuff. Thumbs up because of the algorithms. Subscribe because of the algorithms. The bell notification. I think all the YouTube people tell you to do that as well. I don't like saying all this stuff because it's kind of cheesy, but I think it's probably necessary to, yeah, fight fire with fire, so to speak. So, yeah, thank you for watching, and I'll catch you in the next video.